Welcome to a lesson on solving two-step equations. Remember, the ultimate goal for solving a linear equation is to isolate the variable on one side of the equal sign. And for a two-step equation, it's recommended we perform the following steps. First, we add or subtract in order to isolate the variable term, and then second, we multiply or divide to solve for the variable. And then, of course, we should check any possible solutions. Remember, to maintain equality, we must perform the same operation to both sides of the equation. So let's go ahead and take a look at some two-step equations. If we take a look at number 1, we have 2x plus 3 equals 25. The ultimate goal is to isolate the variable x on the left side of the equation, so we'd have something like x equals some number. So if we take a look at the left side of the equation, we have this plus 3, and we also have this 2 that's attached to the x by multiplication. So we want to undo the addition or subtraction first. So to undo the plus 3, we'll subtract 3 on both sides of the equation. Now the reason we want to do that is plus 3 minus 3 equals 0. So that eliminates the plus 3 on the left side, and we're left with 2x. And then on the right side, we'd have 25 minus 3, which is equal to 22. So now we have one more step. This 2 was attached to the variable by multiplication, and to undo multiplication, we perform the opposite operation, which would be division. So we'll divide both sides by 2. Well, 2 divided by 2 would equal 1. 1 times x would be x, and then 22 divided by 2 would be 11, which is our solution to this equation. And what that means is if we replace x with 11 back into the original equation, it should make this statement true. Let's go ahead and check that. We'd have 2 times 11, since x is equal to 11, plus 3 equals 25. We have 22 plus 3, which does equal 25, and that's our check. Okay, on number 2, we have x divided by 4 minus 2 equals negative 5. Again, the ultimate goal is to have x on the left side by itself. So to undo this minus 2, we could perform the opposite operation, or add 2 to both sides of the equation. This would give us x divided by 4 minus 2 plus 2 would be 0 equals negative 5 plus 2, that's equal to negative 3. Remember, a fraction bar is just division, so this is x divided by 4. So to undo dividing by 4, we would perform the opposite operation, or multiply by 4. Since this is in fraction form, I'll multiply by 4 over 1, so that it sets up nicely. And of course, we have to perform the same operation on the right side of the equation, so we'll multiply by 4. Now notice on the left side, I set it up as a fraction because this is in fraction form. And on the right side, I just wrote times 4 since this is not in fraction form. Here we have a 4 and a 4 that simplify out, so we're left with 1x, which is just x. And on the right side, we have negative 3 times 4, which is equal to negative 12. Let's go and take a look at a few more. Number 3, the variable is on the left side again, so our ultimate goal is to have x equals some number. So notice we have a 4 here, and then we have a 2 here. We have to ask which of these can we undo by adding or subtracting. Well, this is a positive 4, and we can undo a positive 4 by subtracting 4 on both sides of the equation. This 2 here is attached by multiplication, so we'll take care of that in the next step. So we have 4 minus 4, that's 0. This comes down, so we'll have negative 2x equals 10 minus 4, which is 6. Remember, this is negative 2 times x, so to undo that, we'll have to divide by negative 2 on both sides of the equation. Negative 2 divided by negative 2, that would be 1 times x, or just x. And then on the right side, we have 6 divided by negative 2, which is equal to negative 3. Number 4 looks a little bit different because the variable is now on the right side of the equation, but that shouldn't affect our strategy, except that our ultimate goal will be to have some number equals x, where x is on the right side. So other than that, it's very similar to number 3. This is a positive 6 minus x divided by 3. So to undo this positive 6, we could subtract 6 on both sides of the equation. So 4 minus 6, that would be negative 2 equals, this is 0, that's why we did that. And then we have negative x divided by 3. Now we do have to be a little bit careful here. One thing we could do to make sense of this is to put a 1 here as the coefficient of x. So we could think of this as negative 1/3 x. So if we want this to be a positive x, what we could do is multiply by the reciprocal of negative 1/3. Well, the reciprocal of negative 1/3 would be negative 3 over 1, or just negative 3. So we'll multiply the left side by negative 3 as well. So if we take a look at the right side, notice the 3's simplify out. So we have a negative 1 times a negative 1, that's positive 1 times x, which is the x that we want. And then on the left side, we have negative 3 times negative 2, which is positive 6. I think we have time for two more. So looking at number 5, we have decimals, but other than that, the process will be exactly the same. So notice our variable is on the right side again, so we want to have some number equal to x. So looking at the right side, we can undo minus 5 by adding 5 to both sides of the equal sign. This would give us 9.3 equals 1.5x, and then of course minus 5 plus 5, that's 0. Now these two were attached by multiplication, so in order to undo that, we'll have to divide by 1.5 on both sides. So looking at the right side, 1.5 divided by 1.5 would be 1 times x, which gives us the x. And now we have to divide 9.3 by 1.5, and this comes out to 6.2. Now typically, if the equation is given in decimal form, we should express our answer in decimal form, even though this could be expressed as a fraction as well. Okay, and the last problem here, we could solve this equation in 2 steps, but this kind of leads us to the next video on solving equations that require multiple steps. And what I mean by that is often when we have fractions in our equation, the first step is to go ahead and clear the fractions and then solve the resulting equation. So if you take a look at the denominators of this equation, we have a 3, a 4, and a 6. If we can notice that the least common denominator would be 12, the general recommendation is to multiply every term in the equation by 12, and that should eliminate all the fractions, producing an equivalent equation that would be easier to solve. So let's go ahead and see what happens when we multiply each of these terms in the equation by 12, or 12 over 1. Again, the strategy is to identify what would be the least common denominator, and then multiply every term by that value. And now we'll see what happens when we do that. Notice the 12 and the 3 simplify. This would become a 1. This would be a 4. So we have 4 times x over 1. That gives us 4x. Minus, here the 4 and the 12 simplify. This would change to a 1. This would change to a 3. So we have 3 times 3, which is 9 over 1, or just 9. And then on the right side, this simplifies to a 1, this simplifies to a 2. So we have 2 over 1, or just 2. So now you can see that multiplying through by what would be the least common denominator eliminates the fractions and produces an equation that tends to be easier to solve. So this is back to our basic two-step equation. Now we'll add 9 to both sides of the equation. So we have 4x, this would be 0, equals 11. And then divide both sides by 4. So we have x equals 11/4. Okay, that'll do it for this video. Next we'll take a look at solving linear equations that require multiple steps. Thank you for watching.